All right, let's get started. All right, welcome everybody. My name is Jose Anunciato, and our web development room. Okay. Yeah. So let's see. And this is I think CS 5610 section 7, I believe, right? And we'll be here for a little more than 3 hours today. So we'll have a break around 7:30ish, so we can have maybe a bio break and stretch your legs and wake up again, and then we'll start all over again. I don't know how you do it, at this time of in the evening. Just pay attention to me. I'll just try maybe just move around just to keep your eyes moving so that you don't fall asleep on me. I know it's very challenging to be on that side. Yeah, so let me remove that. I moved the setup a little bit so that I can be a little closer to the screen and move around and point and gesture. Yeah, so let's see. So here's the syllabus, and this is all available from your Canvas, which I assume you all have access to. And the intent of this course is to learn about various technologies, web-related technologies, and how they might work together for us to build applications. And many of the strategies that we use here for building applications are the same strategies that we would use to build any software, regardless of whether it's web or not. Okay, we just happen to be using a lot of web-related technologies, right? So we'll be splitting our application into multiple tiers, and we'll first focus the first half of the semester in the front-end tier. Right, we'll do a lot of user interface using React.js, HTML, CSS, JavaScript. And then halfway through the semester, after the midterm exam, we'll focus more on the back end, right, in the middle tier. So we'll create our own server using Node.js, and then hook it up to a non-relational database, MongoDB, right? And we'll do login and registration, and be able to handle multiple users at the same time, and just learn about all the some of the best practices and how is it that you organize applications. A lot of things that we'll learn are applicable to larger applications. The one we're going to be building is somewhat small, and maybe you wouldn't do some of the things that we would. Maybe it's an overkill, an over design. But anyway, I just want to show you what folks are doing out there in industry, what are best practices, how to do it, why not to do it this way. So we'll look at several. Oftentimes, I'll present the way not to do it, just to make a point, and why it's wrong, and what where that might take you the wrong path, and why to instead do it some other way. All right, so I always like to start off with the syllabus. It does have here in the middle, and so I'll come back to this every time we meet, just so that we might know where we are, where we've been, where we are, and where we might be going. All right. So today's the first day, and today we'll be focusing mostly on introducing the course, setting up a development environment, getting you up to speed with the first assignment, and let's see. So and then our next week, we're running this course with other sections. And unfortunately, Monday is a holiday, and one of them is going to miss a class. So it'll make it challenging to make sure that we're all in sync. But I think we'll pull it off. Yeah, so this first assignment is all about setting up the environment. Well, we're going to ask you to download Node.js, install it, and then use it to create your a boilerplate React.js application, and then commit it to a source control like GitHub, and then publish it to an online remote server such as Netlify, right?
And that will be the first assignment. I believe most of you will be done, maybe even this weekend. Hopefully, 80-90% of you are. But I'm sure there's going to be 10-20% of folks who might run into versioning problems, the wrong libraries for the wrong operating system. So it might be a little bumpy for some of you. And so that's why this first assignment is a little bit longer than all the other assignments, just so that we can iron out all those issues, and then hopefully they won't be recurring throughout the semester. So we'll make sure that all the environment is set up so that we can be productive throughout the semester. But then after that, all the assignments are a week long, right? So assignment 2 is like a week after assignment 1, and then assignment 3 is a week after that, and so on and so forth, right? So all the assignments are about a week apart. So it's a lot of work, and also the assignments kind of build on each other, right? So it's not like you can start from a blank slate, and you have to make sure that you completed the first assignment before you can continue to the next one, right? So you really have to be like on top of it, make sure that you complete it, so that you can move on. Okay. So then in the middle of the semester, we do have an exam. So this is probably split it up with a review session, maybe starting the week before. We'll go over a sample exam, and look at some representative questions. It'll be very much like the quizzes that you'll be having throughout the semester. You'll have 4 quizzes by then, and so the exam will be just a really long quiz, right? So you'll already know what the format is. The quizzes and exams are all on Canvas, right? So they're all online. So you make sure you bring your laptop. It's fully charged. The quizzes are no more than 10-20 minutes, but the exam is half the period, right? So we'll do some last minute questions you might have. That Thursday, the 8th week, I think that's whatever, March 3rd, the 27th maybe, or something like that. That Thursday, we'll have the first session. If you have any last minute questions about the exam, last minute review of what you might have been studying for the last week, and then we'll have the exam, which will be about 100 minutes long, and it'll be cumulative, right? So there'll be questions about HTML, CSS, JavaScript, React.js, Redux, a little bit of everything, right? So let's take a look at the topics. So today it'll be setting up the environment, creating our very first React.js application, deploying it to Netlify, right? And just making sure we know what the deliverables are for the first assignment. Again, I'm sure most of you might already be done by by the end of this weekend, but want to give everybody a chance to finish everything up. So it won't be due till next Sunday. So all assignments are due on Sunday at midnight, and Eastern time. And this one is, again, it takes a little longer, but all the other ones are a week apart. So next week, well, actually today we might already get started with HTML, but we'll continue HTML all next week. The most basic stuff, right? We'll the headings and paragraphs and tables and lists and anchors and be able to navigate between different pages. We'll get you started with the second assignment. All assignments have 3 parts, well, except the first one. But most everybody, all the assignments have 3 parts. The first part is all sorts of very generic exercises, kind of like throwaway exercises, just to kind of like a lab, to introduce you to the several skills that you're expected to know, right? And they're all fairly unrelated to one another. They just say, well, how to learn how to do headings and how to do paragraphs and lists and whatnot. So these are all individual, independent exercises. Then the second part of these assignments is applying those skills, right, to build an application, right? And this application is the same application throughout the entire semester, right? So so you'll get started with assignment 2. It'll be the first part of creating this application. And then you'll do the HTML part, and then the week after that you'll do the CSS part. The week after that you'll do some JavaScript. The next week you'll add React.js, and then everything builds on each other. There'll be a lot of stuff that you're going to be reusing. So, for instance, things that you might have written in HTML, just raw static HTML in assignment 2, you'll be asked later in assignment 5 to wrap it inside of a React.js component, right? Just put some JavaScript around it so that instead of being something static, it can now be something dynamic, right? So you can now, instead of just being raw text, now it's something that can be calculated, right? You can put loops and if statements and branching and logic so that you can iterate over data structures and whatnot. Okay. So there'll be a lot of reusing what you've worked on previous assignments and refactoring it. So that's the second part of all assignments. Then on the third part of the assignment is it's a little more labs and exercises, but a little more advanced topics, right? Topics that we don't generally cover for the undergrad folks. And so this just asks you to explore a little further, that to go a little bit beyond what some of the basic stuff is. Okay. So anyway, so that's the second assignment. The third week we'll be talking about styling. So HTML, which we'll cover starting this week today, but completing next week, is all about how do you create the content, right? How do you structure the page and logically and hierarchically, and what are the logical pieces of a page, and what is the relationship between those elements? But it's the raw content. Next the week after that, we'll spend some time on making it look pretty, right? Or learning how to make it look pretty. It won't actually look pretty, but we'll learn the basics of CSS. Right? CSS allows you to stylize your page, right, and establish what colors you want, foreground, background colors, fonts and borders and paddings and whatnot. We'll quickly learn that it's not easy to make things look pretty. You really need to have an artistic eye and to determine that something is ugly. First accept it, and then well, what do I do about it? So it's not easy to make things look pretty, right? It takes an artistic eye. Certainly, my daughter does. I don't. She should make a wonderful artist. Certainly not me. So we'll learn the mechanics of it, right? On how is it that these artists do it, right? What is the syntax? What are all the knobs that you can change, right? But it's really hard to tweak those knobs to make it look pretty. So we'll abandon that effort and say, forget it. I don't know how to make things pretty. I know what they do and how they do it. So instead, we'll use a library that already is a professional library that some of these artists have already vetted out and they've been developing for years. And it's very easy to just apply certain styles, certain classes, and transforms and make our pages look presentable, right? A little more professional. In particular, we're gonna take a look at how is it we can make content responsive, right? And by responsive, I mean how is it that we can make applications or user interfaces that can respond to the size of the screen, right? So that we can have the same content be useful in small screens like a phone or a tablet, right? Or a large desktop, right? And it's usable in all of them, right? So that we can determine that certain things might squish, certain things might wrap, certain things we might hide in smaller screens, right? And only show them when we have larger screens. How is it that we can program all that so that the application is usable at any screen size, right? Yeah, so we'll spend some time on Bootstrap and Font Awesome. Then we'll introduce JavaScript as being the programming language of the web. This first part of in the semester, we'll use JavaScript running exclusively on the browser, right? We'll learn what the basic of the languages, some of the history that it's gone through, and some of the newer versions, and some of the newer features of ES6, and some of the newer syntax that makes the language very much more mature, much more terse, much more comparable to real languages, right? Much more mature languages like C# or whatnot. Okay. And then we'll talk a little bit of the history on how the language splintered with all the many companies competing for our attention. Who is going to control the browsers, the browser wars, and how this splintered the language amongst multiple competing browsers and versions and whatnot, and how jQuery kind of brought everything together and says, okay, well, let's create a veneer or abstraction on top of the browser so that developers don't have to go crazy trying to target all these different versions of browsers, right, from different vendors, from different versions of the language. It was just crazy. So jQuery kind of smoothed that out, right? It allowed us to code to a common API, right, and then left the nitty gritty of translating all these things into the particular idiosyncrasies of each vendor, each version, right? So jQuery is the first version, the first introduction of an abstraction layer, right, between us, the programmer, and the actual browser that we're trying to control, right? So there's JavaScript is the lowest abstraction, right? It's the raw language. jQuery is a little bit on top of that, right? Abstracts the browser. But then the week after that, we'll introduce an even thicker abstraction layer, right? Which is React.js, right? React.js is still written in JavaScript, but it kind of just makes you forget that underneath there's a real browser and there's a whole bunch of idiosyncrasy. It allows you to think about the application in terms of modules and components and functions that are reusable, right? And it allows you really to apply a lot of software engineering principles that we've been learning about reusability, right, understandability, and a lot of design patterns, right, that are common in other more mature infrastructures that we can apply it here, right, in the front end. So we'll spend some time in React.js. Now, all these are introducing the topics, but it's not the only time where we see these topics. Obviously, that's the first time we see it, but then we'll continue seeing HTML all throughout, and we'll introduce new things about HTML as we progress. Same thing with new CSS stuff, new JavaScript stuff. But that's the first time we see JavaScript, right? And then again, in week 6, the first time we see React.js. But certainly we'll continue to use React.js all throughout. We'll also learn about single page application. We'll talk about navigation. We'll have done navigation already in regular HTML, but when we transition to React.js, we'll see that we'll have lost some of the capabilities that we were able to do on just plain old HTML of navigation. So we'll have to rebuild that, right, and use certain libraries, to recuperate some of that lost behavior, and it'll be actually better, right, of what the raw navigation is, right? So this will be much better than the native navigation. We'll also introduce a state management on the front end, like any application, right? Applications need to maintain some kind of state as users interact with the application. The state of the application changes over time, right? As we click and drag and type and interact, right? The data structures in the application change over time. Yes, and those data structures collectively is referred to as the state of the application, right? So there's different ways of managing that state. We'll look at 3 in particular. One is that at the component level, right? How the local variables of a particular class or object changes over time, and then how does that state can propagate across multiple components? How do components interact and share the state amongst themselves? We'll look at the raw out of the box solution, and we'll quickly realize that it has very big limitations of what we can do. So we'll introduce two solutions to that. One is Redux, and the other one is React Context. Right, those two are alternative ways of maintaining state, right, and decoupling the task of maintaining state and the task of rendering that state. Okay, out of the box, they're all in the same, right? They all live in the same place, state and rendering, right, and user interface. We'll decouple those two things, right? Since one of them is, each one of them is complex enough, right, to just have its own particular, complexities, right? So we'll decouple those two. So yeah, there are two ways. One is React Context, and the other one is Redux. Now Redux is has a very steep learning curve. Okay, the first half hour or hour that we'll talk about Redux, I have a lot of blank faces, blank stares, and say, what? Why are we doing this? It'll be very painful that first hour or so. I'm already managing expectations. So that's why this particular assignment is you'll have 2 weeks to complete this assignment. All right. We'll do some really, really simple hello world examples. Okay. And we'll just do it again with another little simple example, and until you catch what it is, right? And there'll be some epiphany when you say, I get it. Okay. It'll be a huge satisfaction when you finally get it. It says, oh yeah, it's trivial. Until you find that you are comfortable enough and confident that you'll be able to do it on your own. Okay. But yeah, it'll take several simple examples and you practicing it on your own. Okay. For you to understand Redux. Okay? It has a very steep learning curve, but nevertheless, it's very, very powerful and is fairly the standard in the industry on how React applications maintain state. Well, large React applications, smaller ones, I would say Redux is an overkill for small applications. If you do some really simple prototype, Redux is way too complex, right? It's not worth the effort. But since the industry in larger applications, definitely Redux is it's kind of the standard. There has been quite a bit of folks moving over to React Context API as an alternative. It's an easier alternative to Redux, but it's not as powerful as Redux, right? So we'll talk about when we use one or the other, right? And or how they could coexist. All right. All right, yeah. So that's assignment 7. It won't be due till until after the break. Okay. So you should have plenty of time to complete that assignment. Yeah, we'll have the exam. We'll have a spring break, and when you come back, the assignment will be due somewhere right after the spring break. Was I hearing something? Hello? All right, so yeah, when we come back, we will focus on the back end, right? So up to this point, we will have only worked on the front end, okay? JavaScript, HTML, CSS, React.js. Okay, so on the second half, when we come back, we'll focus on the middle tier, right? So first, the middle tier, we'll create our own server, a Node.js server. So we'll actually have been using Node.js all this time, right? We'll have been already using a Node.js server to host our React application, okay? But nothing more than that, right? Other than just saying npm start, to start the server, we won't be doing anything else with that server, right? But when we come back, we'll create our own server, right? We'll create our using Express, Node Express. We'll create our own HTTP server and create our own web API, RESTful APIs to provide data for our application, right? So our front end applications running on the browser will have a lot of limitations, okay? Because they're running on a browser, right? They can't access the file system, right? They have very limited access to network access, right? They don't have access to a database, right? So they rely heavily on the help and support of a server who can provide this data for them, okay? That can give access to the rest of the world, right? So we'll create a Node.js server and this React application will be able to go back to the server and say, hey, give me some data so I can render this, right? And so we'll spend a week on that. We'll create our RESTful controllers and services and whatnot, and then we'll hook up that server to a database, a non-relational database, Mongo, which will provide some permanent storage for our data, right? And finally, the last assignment, week number 12, we'll talk about server-side state management. We'll have done state management at the front end using Redux, right, and context, right? But we'll need application server state management so that we can establish a conversation with the server, right? So that the server can identify us, right? Up to this point, we'll have an application where you have a single user, right? So there's no need to identify yourself, right? It's just me. Right? It's just me talking to my application, right? But if you want to be able to maintain, dozens, hundreds, thousands of users using the same application, you need to be able to distinguish who's who, right? So we need to maintain some identity. Folks need to be able to register themselves, then log in, okay? And then, as I'm working with my shopping cart, you're working with your shopping cart, right? Someone else is working with their shopping cart, and we all see our particular information, right? And we all think that it's a single user application, but it's not, right? It's a multi-user application, and the server just knows how to multitask and maintain hundreds of conversations with hundreds of users are simultaneously logged in. Yes, right. So that will be the last topic of state management. So up to this point, you'll have completed about 10 assignments, and 4 quizzes on the first half, and then 2 quizzes more at the end. So after that, on week 13, you will get. I'll start focusing on the project, right? To give you time to work on your project, but also see me work through a project. Okay. Obviously, all the way up to assignment 10, you have worked on a project, right? A product that we've been hand holding you through building this application. Okay. We'll tell you exactly what to do, what to copy, paste here, and complete this, complete that, right? And in a particular order, and it's very rigorous. This is what you have to do explicitly, right? But then towards the end of the semester, I would say maybe the last month of the semester, you will form teams, right? Of either 1 person, 2 person, all the way up to 5 per team, and together you'll work on a project of your choice. Okay, you get to choose. As long as you keep it PG-13, right? You can do whatever you want. All right. Choose a topic, right? Food or sports or movies or whatever, right? Choose a topic amongst yourselves, right? And build an application around that topic. Okay. I'm going to be building an application around movies, right? And so one of the requirements of the projects of any project is that it has to interact with some third-party API that you don't own. All right. If it's books, maybe you can connect to Amazon or Barnes and Noble if they're still around, or Best Buy, or or whatever, right? If it's electronics, it might be Best Buy. If it's food, maybe Yumly has a nice API that you can look up recipes and lots of pictures and steps on how to cook something. Okay. If it's sports, there's tons of APIs out there about that you can retrieve scores and upcoming events and teams and their statistics. Okay, so amongst yourself, choose what topic you want, but that is one of the central requirements of the project. You have to choose a third-party API, right, that allows you to query data, right, and you don't own it. Right? You can't control it. It's somebody else's API. You're going to be building your own API for your project. You own that. You can do whatever you want with it. But the requirement is that you have to interact with some kind of third-party API. Right? I'll be using IMDb. Right? So you can query, shows and casts and plot and poster images and reviews and things like that. Okay. All right. So week 13, I'm going to start several weeks of where I'm just going to build this. Okay, I'm going to build it. You'll see how I got started. And we'll go over through several requirements in the projects, right? And we'll give examples of what we mean, right, about this requirement. Oh, well, this requirement means that you have to do this, right? For instance, one of the requirements is that it has to support logging in, and registering, right? And also you have to have at least, I think it's 3 types of users, right? So for instance, maybe it could be if it's education, maybe it could be a faculty member, a student, right? And maybe an administrative staff, right? So those 3 types of users. If it's food, maybe you have a cook, right? You have a delivery, somebody who can deliver, and maybe a customer who's ordering food from you or something. I don't know. So it has to be 3 types of user, and each user has to have a distinct set of use cases, right? That only that person can do and no one else, right? Like a faculty, they can grade exams and assignments and quizzes, which students can't. But students can take the quiz, right? So they can both interact with the same data structure, right? With the same domain object. They can both interact, where one has read and write access, the other only has read only, right? So you have to come up with these types of users, and what are the use cases that are specific to one user but not to others, right? There might be use cases that are shared, like we all can log in, right? We can all look at our profile, yes. So there are certain use cases that are common to all users, but there has to be at least 1 or 2 things that only this particular user can do and no one else, yes. And that means that it has to have a specific screen or a specific button that they can click, but no one else, right? That is visible to them, but no one else, yes. That one sees the delete button, but the other one doesn't, right? That the other one has an edit button, but the other one doesn't. Yeah. So that's gonna obviously complicate things, and we'll learn how to do all those things. Yes. So anyway, so those 3 weeks or 2.5 weeks, I will be building this. Now I suggest that you don't start the project here. I suggest you start the project much earlier. And you could start the project next week, right? Once you know how to create HTML and CSS, right, you can get started. You can create static versions of whatever it is that you want to build, okay? And mock it up, right? And do some layouts, right? Some early prototyping, yes. You could identify who you want to work with, and explore what APIs you might want to use, yes, right, based on the requirements, right? So I would get started right away. Okay, don't leave it till the last month or so, right? This course, I'm sure this course is competing with other courses for attention, and you have plenty of other things to do towards the end of the semester. So I would get started right away. So those 2.5 weeks will be about projects. It is due on the 23rd, April 23rd. That's I believe that's the last week of the semester. So week 15 we'll have a review for the second exam, and then we will have the second exam that Thursday, the 16th, the week of the 16th, and I believe that is the last week of the semester. So that week also will be, I believe, the week where we're going to be grading projects. Okay, and the grading of the project will consist on you demoing the project to a TA or myself. Okay, we're going to give you a checklist of all the requirements, right? We'll give you the requirements in written form, right? But then we'll give you a checklist that it's kind of like, did I do this? Yes. Did I do this? Yep. Yeah. Yeah. Did I do that? Yep. No. And that's so you'll check it off yourself, but then you'll demo this to the TA, right? And the TA is going to go through that list with you. Okay, to demonstrate that you can log in. You demonstrate that you can log in, right? Okay, demonstrate that you can add data content. You add content. Demonstrate that you can interact with your third-party API, right? And so you demonstrate that, and then the TA is just going to go, yep, and I'll do at the end of that session. you should have a grade for your project. Okay, so that week is going to be very busy, right? The TAs are going to provide slots for you to register, your team to register for those demos, right? Choose a slot. I'm sure most of you will choose the ones towards the end of the week, right? So those slots get filled up real quick. So yeah, and you'll demo it that day. Usually by Thursday or Friday of that week, everybody will have a grade for the project, and I can submit final grades by May 1st. Right, I have to have grades in by May 1st at 2 p.m. Okay. Yes. Yes. Level of work you need to output, like, is there a general rubric on it? So we used to have a rubric that was per size of the team, and it was a nightmare because there was so much variability on what folks would do, and there was like a negotiation back and forth. Like every team, there was a very specific negotiation of, hey, if I do this or I don't do that, and it was very hard to have something that was standard. So we abandoned that. So just everybody does the same thing, no matter what the size. I mean, we would, if you're by yourself, we'll be much lenient for if you're on your own. Sure, we'll go a little easier on you. But on principle, we're not going to have a rubric for different sizes of team. I would actually discourage you from larger teams. Okay, larger teams tend to be harder to manage, right? You tend to have one or two in that team that are slacking off, right? That are the ones that least participate or go MIA, and usually there's some drama towards the end of the semester that, oh, I did everything, but some stuff didn't do anything. I'm scared about my grade. I don't want to hear any of that. Okay, large teams are typically very hard to manage. Right? That's why there's a whole course on software engineering on how to manage larger teams. Okay, it's a nightmare to work with more people with bigger teams. Okay, and there's a whole strategy on how to deal with that chaos. So I would actually discourage you from larger. I think the perfect team size is between 2 and 3. Actually, the appropriate size for a team. But folks have always asked me, oh, well, no, but we're 5 people. We love each other. We've been together since the beginning of the grad school, blah, blah, blah. We totally trust each other. Okay. If you truly trust the people that are in your team, go, have at it. But I don't want to hear, any drama of people slacking off or whatever. You have to trust whoever you're joining. Okay. If there's drama, I need to hear it very early on to be able to do anything. Okay, if it's the last week or like 2 weeks before the due date, it's too late. I can't do anything. Right? It's too hard. No, I don't want to deal with that drama. Yeah. So please, I think 2 or 3 are great. Also, I will create teams on Canvas, and you need to join those teams, right? Even if you're one person, you need to join a team, right? But that's the only way that we can give you a grade, is that if you join a team, even if you're just one person. Also to create a team, one person in the team decides, choose one of you in the team to join an empty team on Canvas, so you can take ownership of that team, right? And then tell your other teammates, hey, I joined team number 24, right? So everybody else can come in and join team 24. Okay, so this should work fine, mostly. I'm sure there will be 2 people that both choose the same exact empty team, and they end up 2 people that are not in the same team end up in the same team. So somebody's going to have to, choose some other team, right? So we'll let me know if you need help, but it should be okay. Yeah, so it's 10 assignments and it's 40% of the grade. There are about, I believe, 6 quizzes, and that's 10% of the grade. The project is 30%, and then there's 2 exams, 10% each. Right. The final grades, and these are the letter grades. Late submission policy. So policy is really simple. Everything's due on Sunday evening at midnight. If you need extra time, right, you don't need to ask for permission. Okay. If you need 2-3 hours more to just wrap up, just take those 2 or 3 hours, right? We're just gonna deduct whatever hours you are late. We'll deduct it from whatever you would have gotten. Okay. So obviously, if you're 100 minutes late, hours late, then obviously it's 0. Okay. So yeah, don't do that. Obviously, there's exceptions. If you're sick, right, or there's some kind of family emergency, we'll definitely we'll help you through any of those emergencies. We want to give you any support that you might need. And if there's an emergency, just do whatever you need to do. We can figure out later. Okay. Also, I know some people might be traveling for a conference, or maybe you're on a sports team. Just let me know. We can also work something out. On the project, the assignment, the product that you're building in the assignments is very specific, right? We ask you to very specifically use a particular technology stack. Now, React.js for the front end, Bootstrap for the styling, Node.js for the middle tier, and MongoDB for the database, right? For the project, you are welcome to explore other things, right? If you want to try Vue.js or Angular or whatever for the front end, be my guest, right? That's a great time to start exploring other things. For the middle tier, if you want to try out C# or Python or Ruby or Java or whatever, right? Go ahead and do a middle tier using something else. Okay. If you want to try a relational database instead of a non-relational database, want to try MySQL or something else, or Firebase, or feel free to explore. Okay. So in the project, you are much freer to explore whatever you want to take a look at. All right. Obviously, there's some functional requirements that all projects must meet. Okay, regardless of what technology stack you choose and whatnot, they all have to have some type of functionality. We can negotiate the functionality, right? If you think that the requirements are too restrictive and you want to do something way out of it, that falls outside of the requirements, I think our requirements are fairly generic enough that to apply to most applications. But hey, if you have some really cool something that falls out of it, I'm willing to negotiate some functionality. All right, and so let me know. But we'll go over the requirements a little later. Assignment. Yeah, so the assignments are meant to be worked on your own, right? Those are you demonstrating some skills, right? So it's all you. It's okay if you find something on Stack Overflow, a couple of lines of code here and there that don't actually solve the assignment, right? If some utility library or some utility function or something, that's totally okay. Just say where you got it from, right? I got this from Stack Overflow, blah 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 blah, whatever. That's totally fine. But don't blatantly just copy from some of your teammates or from folks from previous semesters. Don't look around. Just stick to this semester. All the source code that I work here, I do a lot of live coding. I will be providing all the live coding in GitHub, and from there you can copy all you want, right? You can read, and I even ask you, use the code that I used, last night and blah blah, and copy that, yada yada yada, whatever. Yeah, that totally is okay, right? But yeah, don't start wandering and looking for previous semesters or anything like that. The TAs that I have been with me for several semesters. They're familiar with other projects from previous semesters, from assignments from previous semesters, right? So and they're very good at identifying, if there's somebody copied something, please, don't put me in the awkward position of having to report you. I have the university. I'm required to report you if I have any doubt that your material is not yours. I need to report you. Don't put me in that awkward position, please. Especially on a spring semester when people are graduating, the family's coming over for graduation, and there's a lot of crying, and I just please don't don't put me through that. Okay, I think that's it. Oh yeah, if you have a disability, just reach out to me and we'll support you. Okay. Any questions? Yes. I would say at least 10 hours, 8 to 10 hours. Yeah, sometimes more. Like especially in the Redux assignment, I think that's going to be more like 20 hours. That particular assignment. That one's really challenging. Yeah. Okay. So obviously we have a Piazza, and you might have already seen a lot of conversations and questions from other sections. There are two other sections that are in parallel with us. One is an undergrad section, 4550, and another 5610, which is online, remote. So there might be a few things that might apply to a specific section. I'll make an effort to tag that specific section, right? If it's something specific to that audience, right? Otherwise, most everything should apply to everyone. Okay. But I'll make it explicit. Also, we have office hours. We have office hours for. I have office hours specific to this section. Actually, I have it here. Here, office hours. If you go to office hours, these are my specific office hours, which are every morning, Tuesday, Wednesday, and Friday from 8 to 9. And then the TAs have their own office hours, right? So Saiteva has from 6 to 7 on Monday and on Saturdays. So I listed them in chronological order. So I'm here at 8 in the morning, then Vishal at 9, then Kartikev at 10, Vinayaka at 11, and so on and so forth. Okay. I also created a little map. I think this might be easier to read. So this is where is everybody at during the week, right? I'm trying to push more office hours towards the end of the week because that's when the assignments are due. And I imagine that Saturday and Sunday folks are going to need a little more support for that assignment. So I'll try to, not on Monday, since I imagine that when you submit your assignment on Sunday, you kind of want to clear out your mind and not think about web dev for a day or so. So we have less support on Monday, right? But as we progress throughout the week, we do have more support. Okay. So yeah, those are office hours, and please make use of all those office hours. Let's see. All right, so there's a required text. It's an online required text, and there's some reading each week that there'll be a couple questions on the quiz and the exam and whatnot. Okay. All right, so let's see. What are we doing this week? Transcripts. The participant has enabled getting it. Okay, so let's talk about web dev. All right, so what is web dev? what is web development? So first of all, what is the web? And then that necessitates the question on what is the internet? Why is this? Huh? Wait. Click to join. Let me make sure folks can still hear me. Can you all still hear me?
Yep.
Can you still hear me? Yay. Okay. All right. So what is the internet? So the internet will go away. So the internet was our attempt at surviving World War III, right? We had just come out of World War II, and everybody was asking, how do we beat the Germans? Right? What do we do? And it turns out that we just bombed the heck out of them, right? We just just destroyed all the roads, all the telecommunications, phone lines, and just made it really, really hard for them to communicate with one another. And it was really, really hard for them to coordinate any attack, defense, or anything like that, right? So we started thinking of, what if this happens to us, right? What can we do to avoid being vulnerable this way, right? So the War Department or the Defense Department was tasked to look into this, right? What can we do to create a robust telecommunication network, right? That is very robust, very redundant, right? That there is no single point of failure, right? That you can bomb and you could still establish a decent amount of communication amongst ourselves and coordinate a defense, right? So in the early 60s, so we started, DARPA, the research arm of the Defense Department, was tasked to investigate what can we do. And soon after, they started coming up with different versions of or iterations of different networks, right? And by the late 80s, it started being opened up to academic research institutions, right? And in the 90s, it became commercial, and then it was history. In the 90s or in the 80s, folks were, the military was looking to make this available commercially, and everybody was scratching their heads, says, what could you possibly do with this? How could you possibly make money out of this? Nobody had thought of anything back then, right? So then in the late 80s, one of these research institutions, in that CERN, Tim Berners-Lee, all by himself, invented the World Wide Web, right? He was just a physics research that was just wanting to share his research results with his fellow researchers, right? Be able to show his results in some kind of table, right? With all formatted as a research paper, where you have maybe an abstract at the top, have lots of headings and paragraphs and lists and tables and images, and also references to other research papers, right? Where you have at the bottom, you have references, and also right next to a particular blurb or particular text, right? You have that the symbol to 1, 2, 3, and these are links to other research papers, right? And so he wanted to be able to quickly click on those links, right? Go to see that research paper and then easily come back, right? So this is what he had in mind, right? Now all the technology that he needed was already invented, okay? All through the 60s and 70s and 80s, we had already built, right, the internet, and tons of little, disjoint applications, FTP, UDP, SMTP, all these protocols that were for different use cases, right? For sending email, right? For transferring files, right? So all this already existed disjointly, right? Kind of like in the ether. What he did, right, was just take all this technology and apply it to a particular, very concise, very focused use case, right? I want to very quickly be able to with a text editor, a simple text editor, just edit a document, right? I want an easy way to just render it easily with an application. I want to be able to store this in a centralized server, right, where you have lots of research papers, right, and a way for you to they link to each other, right? So he inadvertently created the first HTTP server, right, to host all these HTML documents. Invented HTML as the format for formatting these research papers, right? And and then the rendering engine, the first browser that would go and fetch these HTML documents from the server, download them into to your local machine, render it for you, right? And the mechanism of just rendering, and obviously be able to click on a link and then go and fetch another document, right? And replace the one that you're looking at, right? And the notion of doing a backspace, and you go back to the research and then forward, backwards, right? Maintaining a history of all the research papers that you've read so far, right? So you can go forwards and backwards in history of all the research that you're looking at, right? So it was very humbly, he had a huge impact on the world, right? There was a very simple idea, and it just took off like crazy amongst all the research institutions, right? Soon after, all the different research folks at different universities started using it. Then all the graduate students were using it. Then all the students at the universities were using it. Then it made itself into homes and into entrepreneurs and companies that were looking to cash in on this very easy way of creating content. Right? What he did is lower the bar of entry into anyone being able to create content. Right? Anybody just publishing anything for anybody to read, right? Which created a huge problem. Says, okay, well, if anybody can create any content that they want, how does anybody find anything? Right? How do I know that somebody published something? There's no way for me to know. This created that huge problem created a huge opportunity, right? That somebody cashed in on that. Mosaic and then Google search obviously cashed in big and still cashing in on that idea of just indexing the entire world and telling everybody where everything is, right? If you just with a simple set of text queries, right, it comes back with all the pages that are available, right? And then ChatGPT just screwed everything up, right? So now there's no searching. You just ask a question and the Oracle will answer. So yeah, I don't know where that's going. So the web. He inadvertently invented the web. And so he created the first browser. He created the first server. The idea of using these URLs. Obviously, all these ideas already exist. Okay, he just found a very niche, a very peculiar use case for all these technology, right? And kind of like what the iPhone did, right? I mean, everything was invented before the iPhone. I mean, you had small handsets, right? You had graphics, and you had the internet. You could connect to the internet. Everything existed. Just that somebody came along and says, "Ooh, how do we wrap it up and dress it?" And then everybody then became an iPhone copy, right? Anyway, so URLs or uniform resource locators is how you refer an index, right, or access all these pages that millions and billions of people are creating, right? And all these documents live on some server, right? And the idea is that to retrieve any document, you need to know first in which server it's in, right? And the file might be under a particular file path, right? And some directory structure. And so URLs, right, it allow you to specify the name of the machine, right? And then the path to follow to then retrieve a particular HTML document, right? And the server responds with this. It says, "Oh, you want that document?" It'll go fetch it. That path finds it and then sends it back to you as a response, right? And then the browser renders it for you. Very, very simple. All right, so just a couple of historical milestones. In the 60s, obviously, we have the evolution of the internet. Then in the 70s, there were a lot of iterations on the various roles that these computers connected to this network, right? What were the roles of these computers, right? And there was a overarching pattern of what these computers were doing. Okay, they have very specific roles, and they ended up having any one of these two roles. One, computers that were specifically servers, and computers that were clients, right? And together they had a contract amongst themselves, right? A protocol that they followed, right? And where the servers were responsible for holding the data, the files, resources in general, right? And then making it available to any number of clients, right? So the servers used to be, these huge, very powerful machines, right, that were in some, dedicated room, maybe air conditioned, very clean, and needed a lot of attention and maintenance. And then you have these clients that might have been, very, less powerful machines, maybe just a terminal and a keyboard, right, that had very little computation power. And all the requests went out from the client, went out to the servers. The server would compute something, right? Find a file or do a computation, and then come back with the response for the client, right? This architecture of these responsibilities is still with us today, right? It has survived a lot of decades of scrutiny, and it's still with us. I mean, lots of architectures have come and gone, right? But this one has really stuck through the ages. Then came the personal computers, where you no longer had these dumb terminals, right? Now these machines could be somewhat fairly powerful, and they were cheap enough that I could take it home, right? They weren't tethered to this centralized computer. I could actually take it home, right? And so now, instead of this big mainframe server computer running the software, I could actually take the software with me, right? And my rinky-dinky little machine was powerful enough to run that software on my personal machine. This obviously disrupted immensely how software is developed and how it's distributed. Before, it was one single place. You update the software in one place, and all the terminals just access the same machine, right? There was no distribution. It was just one place. It was running all in one place. Now everybody took it home, and you had to distribute things with CDs and floppy disk and AOL sending you tons of these CDs everywhere, right? And you have to install them and hard drives and blah blah blah. So it was an interesting development. Then came the World Wide Web, the internet, an explosion of content, how to find things, and the commercialization of the internet, the commercialization of the web, right? And the fact that folks were having ever more powerful computers, right? That could run a lot of the tasks on the computer instead of a server, right? And more powerful rendering engines, rendering 3D images and CPUs and GPUs, right? Ever more powerful. And then in the 2000s, after some iteration over the World Wide Web, it kind of evolved. The World Wide Web evolved from this static content, kind of like brochure, like magazine, newspaper kind of thing, into a much more dynamic, implementation of things that would change over time, like weather applications, right? That can change over time. When every time you visit them, it's different, right? As opposed to something that is static, that could be maybe just a magazine article that doesn't change over time, right? And then video, right? And then animation and all kinds of really interesting things. In the 2000s, folks started to realize that hey, the internet and the World Wide Web is actually a new platform for us to develop software, right? And all the techniques and strategies that we know how to develop software for desktop, we could use a lot of those same strategies to develop software for the web. it's different protocols, different. It has to be architected slightly different. It's client server, middle tiers, and yada yada yada, right? And so it's when folks start to think of the web as a framework for building applications. Then the mobile computing in the 2010s, right, where now it evolved from these monolithic huge machines, right, evolved to then a desktop on your at home, to then the supercomputer that you can just put in your pocket, right, and go anywhere, right? And then just an explosion of people, interacting with the web, generating tons and tons of more data, right, of their location, of their searches, their queries, right? Every time we wave our phone, we're generating a huge stream of data that somebody's storing in some database, right? And they're trying to mine it for patterns and try to sell you something, right? So this huge big data, this amount of data that is being accumulated, is what is feeding the future, right? Feeding the future of artificial intelligence, connectivity, Tesla bots, ChatGPT. Who knows? Where are we going? Where are we going to end up? So meanwhile, at the same time, in the early 90s, soon after Tim Berners-Lee invented the World Wide Web, a lot of companies started saying, "Hey, how can we make money out of this?" Right? And so they started finding some limitations of what you could do with HTML. Right? It's static. What do I do with static things? I can only generate so many magazines and so many brochures and newspapers. Right? I want something that is dynamic. I want to build something that you come in this morning and you look at the weather and it says that it's raining, but then if you come in this afternoon, it'll say that that it's nice out, right? And you can come out now. You can come out and play now. Okay. So I need applications that are not static. They need to evolve over time. Yes. Also, what about if I go and I have a preference? I want to have my own shopping cart, right? As opposed to Alice's shopping cart. Bob wants another shopping cart, right? So we want to be able to both of us have our own information that is specific to me, right? So how do I do that? So I want to be able to personalize this and have conversations with individual users, right? And also I want this to be dynamic and change over time. So the HTML and CSS, that was impossible, right? So there was a plethora of solutions to this problem. They were based on the first basic foundation of the common gateway interface, right? Where what folks were looking at, it says, well, what if instead of browsers and you're asking for a static HTML document, what if instead of doing that, I mean, that's already going to a server, right? And the server is looking for this file on the file system. What if instead of doing that, you don't ask for an HTML file, you just ask for a particular URL, whatever, okay? Could be add 2+2, right? Slash something HTML math.com/add2+2, right? And so that could go out to a server. The server could parse this, okay, and then run some code, right, and then calculate the results, okay, and then spit back that response. And it could spit it back in a format that the browser understands, right? It can spit back HTML, with headers and paragraphs and blah, 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 right? Nicely formatted, some CSS, but it's content that is dynamically generated by the server. See that? So instead of you accessing a static HTML file, right, you're actually running some software, right, that is calculating the response. And that could be written in anything. It could be written in Perl and in C++, right? And this idea just took off like crazy, right? Tons and tons of folks, jumped on this bandwagon. And one of the more successful versions of this idea was PHP, okay, which allow you to combine, static HTML, embedded code, right? So now you could have, C-style programs, right, that had loops and for loops and if statements and branching and database access, blah, 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 right? Embedded with HTML. So code that ran and it calculated what HTML was going to be spit out to the browser. See that? Okay, so instead of looking for about.html, you would be going to about.php, right? And .php would be an executable that would run on the server, and it would calculate what the HTML would be dynamic. Make sense, right? So anyway, so that started a huge war amongst the large companies, right? The Microsofts of the world, Sun Microsystems, Oracle, right? All these large corporations, jumped on this technology, okay? And the first successful, coalescing of these strategies was done by Sun Microsystems in the Java 2 Enterprise Edition, right? Before then, it was kind of like the Wild West, right? Everybody was doing whatever they wanted, right? And everybody was just inventing the way things should be done, okay? But certain patterns started to appear, right? After people had worked on 20 projects, they learned enough not to do certain things and to do certain things the correct way, right? So those design patterns that appeared, coalesced into what was known the Java 2 Enterprise Edition, right? Where you see a lot of those first design patterns of, hey, how about a good way to build these applications is to follow these industry standards, right? So a design pattern that works very well is the model view controller design pattern, right? You have the model that does the data, you have the view that does the rendering, you have the control that you have your logic, right, of the application. Okay, so that became very successful. It was purchased then by Oracle. Then .NET kind of did the same thing, built on the same idea of the model view controller, but expanded it even further and made it even better. Okay, so and there was lots and lots of movement and ways of doing this and how to compute. Basically, all these did the same thing, right? It was compute HTML on the server. That's all they did, right? Is a way of breaking up your code in such a way on the server side to generate dynamic HTML, right? They all do the same thing, right? Different languages, different strategies, but in general, that's all they do. Okay. Even Node.js, in the late 2009. Now JavaScript had been up to this point limited to be executed only on browsers, right? This is code that can run on browsers. It was finally liberated in the 2009 so that it could execute not only inside of browsers, it could execute also on desktops. Okay, and this is where we are right now. And that's what we're going to be using. Flask, Python, and lots of server-side solutions to generating dynamic HTML. Okay, so in tandem, at the same time, there were a lot of things happening on the browser side. Okay, a lot of competition there as well, right? The Safaris and the Chromes and the Mosaic and the Netscapes, right? All these were competing, to be the next, window to the world. Okay, different companies thought that they had their market cornered, right? And then they when the World Wide Web came in, kind of started eating into their game, right? So the first foray into code that executes and runs is in 1995. Netscape comes up with JavaScript, and so this idea was that instead of the server running code and generating dynamic content, how about we have code that can run on the browser, right? And from the browser, you can dynamically finagle with the content. You can dynamically generate content in the browser as opposed to generate it on the server. Now, on the server, it's much more powerful because you have access to the file system, you have access to a database, right? You have unfettered access to the network, right? So you can build a lot of very powerful things on the server. On the browser, you're kind of limited, right? You don't have access to the file system, you don't have access to a database, right? And you have very limited network access, right? So progress on the browser actually was much slower, right, than progress on the server side. Okay, because there was a lot of limited stuff. Also, people were kind of weirded out that saying, "Wait a minute, I'm downloading code from a server that I don't know, and then running that code on my browser. Yeah, that's scary, right? I'm running somebody else's code, downloading, and then execute it here on my local machine. I don't want that. So there was a lot of pushback early on with this idea that I'm downloading JavaScript and executing. No, I don't want that. So it was very limited. Folks were just using it for very simple validation, form validation. A lot of cat videos and little simple games. So it didn't progress much, and JavaScript was a very, very immature language, and it still was still a while ago. Yes. Well, yeah. I mean, at first there was no limitations on accessing your file system, right? Or being able to navigate through private stuff in your or listening to your keystrokes and sending it over to any network. So what the folks did to kind of get some trust from the community was to limit the browser, and says, no, we're going to limit the browser, right? And any code that gets downloaded can only do certain things, very limited things, such as it has no access to the file system, right? Other than caching or things, or saying, well, only to this particular folder. Okay. It can't just connect to any network and talk to anybody. It can only talk to wherever it came from. Okay. It doesn't have unlimited access to the user interface, so that it can control your user interface, right? Start clicking stuff on your screen, right? So it has a lot of limitations that, again, were invented at a time where we had a lot of mistrust on things being downloaded and executed locally. Something that actually Adobe was able to get around and says, well, Adobe was very, very successful with its solution of the Flash Adobe Flash, right? That became very, very popular for about a decade, right? They dominated that space very, very strongly. So they get around to it saying, well, the browser is very, very not very powerful. How about you install this plugin, right, where you can then download software that runs instead of this plugin, and this plugin is very safe. And they were able to market this very, very successfully. Okay, so people didn't trust JavaScript being downloaded and run on the browser, but they were okay with downloading, compile object code from Flash and running it on their browsers, right? So anyway, they were very, very good at marketing this solution, and it just became very successful. Everyone was playing, all sorts of Flash games and Flash animation, and for education purpose and for marketing was it just boomed like crazy. Okay. But there was still a lot of effort to make JavaScript something, right? So not until we got to Dojo in 2005, we start to see some frameworks actually be built around JavaScript, right? Some serious frameworks for implementing applications, right? In the mid 2005s. Also, one thing that really made it really, really hard to develop anything was that the browsers had splintered into so many different versions, so many different vendors competing amongst each other, right? Especially Internet Explorer, right? That had gone on its own way and had its own version of JavaScript. All these companies trying to lure developers to their platform, say, hey, develop for my browser because my browser does this and their browser doesn't. Okay, what it did actually, it just made it hard for everybody. Okay, so jQuery solved that. jQuery came along and said, hey, I know that everything's splintered, all these different versions, it's a nightmare. Okay, how about instead of you coding to a specific browser, you code to a specific API, right? And I will translate correctly for the correct browser, for the correct version, so you don't have to. You just code to this middle API, this abstraction layer, right? And I'll do the translations if it's IE, if it's Chrome, if it's Safari, I'll do the right thing. Make sense? Right? Kind of what Java tried to do, right? Where you code once, run anywhere, right? Where presumably you coded one single Java code base, right? But then it would run on Windows, it would run on Mac, it would run on Linux, it would run on anything. Yes. It actually turned out to be, code once, debug everywhere, right? So anyway, so jQuery tried to, very, very successfully was able to solve that. A lot of more evolution of many different frameworks. Not until Angular by Google came around that we actually had a very mature framework for building JavaScript applications on the browser. Okay, these guys really went out. They were 10 years behind Java, right, and .NET and all those folks. So what they did is they copied a lot of the same ideas that were very successful on the server side, right? All the design patterns, right? The singleton design patterns, the data access object design patterns, services design patterns, controllers, all those great ideas, model view controller that were very successful on the server side. They copied those design patterns and applied it to the front end. Okay, and Google was extremely successful. Now they made a huge error, right, when they went from version 1 to version 2 in Angular. And version 2 is not backwards compatible with version 1, right? So all the companies that had, invested, millions of dollars, right, in developing their applications using Angular 1, found themselves that none of that code was forward compatible, right? If they wanted to migrate to Angular 2, they kind of had to rebuild the whole thing. They had to recode everything. So all the investment that they had done before was not going to pay out for Angular 2. So they were very mad. A lot of companies abandoned Angular, and they started looking for other alternatives. As well, if I'm going to have to build this again, what other alternatives are there, right? And React was there to welcome them with open arms, right? Folks started looking at React as an alternative for the rendering of the rendering engine for the user interface, right? And React.js just became still today is one of the main front end framework. Well, it's not a real framework. It's libraries to render very simple functional modular user interfaces. Okay, all right. So anyway, that's just a very brief 25 words or less history on where we've been. Anyway, so this is the architecture of what we're going to be building this semester. The first half of the semester, we're going to be spending it mostly on this side, on the client side, creating a application that runs on a client. Our client happens to be the browser, but it could be a desktop app, it could be also mobile, right? So this client or our browser running JavaScript, running React.js is going to be talking to a server, which will be focused on the second half of the semester, right? Which is going to be a Node.js server that is going to be hooked up to a non-relational database, MongoDB. Okay, so it's a client-server application, also sometimes often referred to as a multi-tiered application. Right, so the front end tier, we're going to do the middle tier in the second half of the semester, right? And you have the database. So this is where we are, right? The client is going to make a request, and then the server is going to make a response, right? All right, so this illustrates the evolution of how rendering has evolved over time. Right, so for the first 10, 20 years of the World Wide Web, this was the main strategy for rendering dynamic content, right? The browser, a user would request a page, okay? And that page would be written either in PHP or JSP or ASP or Python or some server-side technology. The server would execute, right, and would calculate what the HTML result would be, all right, and then send it back to the browser. The browser would see this as if it were just static HTML, right? It was just text. It didn't know that it was dynamically generated, right? As far as the browser is concerned, this is static text, right? And it could not distinguish from the server generating this or an actual file, ASCII file, right? It could not distinguish that, right? And then it would just render for the user. So this was the strategy for the first 15, 20 years of the World Wide Web. Okay. Now, when Google came along, they followed a different strategy, right? Which that strategy culminated in Angular, right? As being their framework for implementing this kind of applications, right? But they have been doing it for a while already. Of which one of the first time that it became apparent the difference between this and that was when I used Google Maps. Okay, does anybody remember MapQuest? Yeah, MapQuest, right? Before Google Maps, their strategy was this, right? You would interact with a map, clicking buttons, right? And those requests would go out to a server, and the server will calculate the next map. Right? So if you want to pan right, pan left, zoom in, zoom out, right? That would be a new request that goes to a server, and the server would calculate what next map you would see, which is fine. It was totally fine, right? It could do everything Google Maps could do, okay? But, the first time you use Google Maps, right? And you could, just grab the map and start jiggling around, right? And just flick it, right? And then just the map would just animate and bring in more, the smooth implementation of that. It was just, oh my goodness, right? This is something completely different. Okay. One was the MapQuest was very jarring, right? Because every time you clicked on it, it would re-render the entire screen, right? It would flicker. It was not a very smooth interaction. Okay. Completely the opposite with Google Maps, which provided a very, very smooth, right, interaction where most of the content was static, but only certain things was dynamic, right? And it was very, very smooth. So that was that implementation is this one, right? Where you go and fetch HTML from the server and JavaScript, both HTML and JavaScript, and the HTML is a template, right, of what the content should look like, right? And then when the JavaScript came to the browser, it would start running inside of the browser, and it would realize that it needed some data, right? It might come down. It would download also maybe some initial data, perhaps, right? Like Google Maps might download an initial map based on your location, GPS location or something. Yes, your regional by IP address or something. Yes, but then as you interact and you do something with the application, the JavaScript would send requests back to the server, right, with additional information that it would need to fill in the blanks, or as you scrolled or as you interacted with this, it would fill in the empty spaces, right? In Google Maps, it would be the empty images, right, to fill in the world that was missing, right? If on Facebook or Twitter or whatever service, if you start scrolling and it's an infinite scroll, right? It's actually making requests, right, to the server to fill in those blanks, right? It's not downloading thousands and thousands of tweets, right? It's just fetching the next 10, the next 10, the next 10, the next 10, right, to fill in the empty spaces. Yes. So this approach right now is the most modern approach of building user interfaces, where you do the rendering mostly on the client, but you rely on the server for data or images and resources that this JavaScript needs to go fetch back from the server, because the JavaScript doesn't have any of this, right? The server has all this. So it goes back to the server, but for data, right? For images, not for content. Again, not for HTML documents. Make sense? Right? So actually now it's both of these are now combining their strengths, where one might lack the other. For instance, one of the limitations or one of the weaknesses of this strategy is that you download the template, you download the JavaScript, but the content is still on the server in a database, right? And so there's a lag of time between the time that it starts rendering the template and having to go back to the server for data, download that data, and then dynamically render the screen. And that might take a second, maybe two, right? Where maybe you're spinning, right? Because you're empty and because you're waiting for the data to come back from the server. Yes? And people are maybe not too lenient or patient to wait for 1 or 2 seconds, right? They might go away, if they have to wait for half a millisecond, okay? You either grab the attention of the user within those first half second, or they're gone, right? They might go somewhere else. So for that, for very fast performance pages like the landing page, yes, where you want to grab the attention of the user right away, they might use this strategy, right? Because this is backed by very powerful servers, right? That can generate and pump HTML very, very quickly. Okay, that as far as the browser is concerned is static, right? There's no spinning or anything, right? It gets the entire content pumped right to the browser right away. There's no computation on the browser side. There's no lag time. Yes. So for very performance pages, this strategy is still popular, right? So there's a combination between the two. Okay. But we're going to be spending most of our time in this strategy. And this strategy is referred to as the single page application strategy, right? There's a single page. You only ever download a single page with the JavaScript, and then JavaScript is then responsible for fetching the rest of the content and animating the screen, making it look as if you're navigating and things are changing, but you're only ever in the same page. You never leave that one single page, right? So they're referred to as single page applications, right? Whereas this one, you're navigating from one page, maybe to another page, and then maybe to another page, right? And they're all jarring and flickering and not as smooth as an interaction. Okay. All right. Okay. All right. So let's take a short break, and we'll come back right after these messages. And let's go stretch our legs and walk around, get some blood pumping in there. Oh my goodness, what's going on?
Sorry. Mohammed,
How you doing?
I had a quick question. So I did the notes for the web app, but when you go in, are you meant to do it from the directory above it? Like, should I have that?
No. Yeah, you have to open that. Yeah, don't open that.
Okay, that's what I thought. So it's
Yeah,
one
yeah,
directory further in.
Yes. Yep.
Okay, cool. Just wanted to be sure.
Yeah.
That's great.
How you doing?
Good, thank you. So we're actually, both of us, we're on the wait list. Yeah. So number 3 and number 6 right now, I think.
Okay.
I guess a couple follow-up questions given that. We're not really able to currently access Canvas.
Okay.
So
Yeah, if you put your emails and UIDs.
fantastic.
But for now, you have to observe your camera registry. So you'll be out to the public. Has to be your NEU. Oh, really? Usually, oh, yes.
So no, I was. Exactly.
There you go. All right, are you okay?
No.
New Yorkers have like a swimming. And then if you live in New York, you go out. Sure. Oh, okay. Yes. And why are you? Okay, so. Okay. And other ones? Because if there's one flag project, then they rank the requirements. If you're undergrad, then you're all on if you're all undergrad, yes, undergrad, only for the undergrad requirements. Okay. All right. So get it? There's more requirements for the project and the assignments. Quizzes have different requirements, more work. The undergrads, they have a Parker schedule for the grads. They have a really crazy schedule. I don't know why they take so much work to get there.
Yeah, maybe we have. Well, I'll take it.
All right. Hi, can you all still hear me? Awesome. Great. All right.
What's next for you after this year? Sorry, that's a curious question. That's so awesome.
All right. So let's continue. Let's see. Yeah. Enough history. Let's do some real work. Let's see. Yeah. So for this week, let's get you started with the first assignment. Assignment number 1. So for this assignment, you're asked to create, get up and running on an environment, set up your environment for a development environment, right? So that means getting your IDE installed, downloading and installing Node.js, and creating your first React.js application, installing a Git client. Is everybody good with Git? Who has experience with Git? All good? All right. So you'll be pushing your contents to a source control like github.com, and then deploying this to network. All right. So I will demonstrate on my own machine what the assignment entails. I assume that most of you will be done by the end of this weekend. Some of you might need a little longer. That's fine. We'll get you going. All right. Yeah. So the first thing that we ask you to do is to choose an integrated development environment, an IDE. I'm going to be using IntelliJ, but if you want to use Atom or Visual Studio Code or WebStorm or something like that, that works as well. Okay. You can download it from these links. And for IntelliJ, if you register with your university account, you can download the latest version. I would download Ultimate. Ultimate is their top tier product, right? And it's free, I believe, for a whole year, maybe even 2. Okay. So that totally would work. But definitely you'll need some IDE to help you through your source code. Okay. The other thing is that we're going to need a server to host our local environment, right? And we're going to be using Node.js. Right? So you'll need to download Node.js. You can download it from nodejs.org. The latest version is 18 or 19, either one will work. And you download it and install it for your particular operating system, right? Whether Windows or Mac. Now, when you install it, it will install a couple of executables, okay? Of which there's several executables, of which we only really care about 3 of them, right? So first of all, what is Node.js? So Node.js is it's a framework. It's a runtime that allows you to execute JavaScript on the desktop. Okay, so we are going to be using lots of languages in this class. HTML for building the web pages, the front end, CSS to make it look pretty, JavaScript for controlling the browser, right? Now JavaScript, by default, is considered to be a language that runs on a browser, right? That's where it became famous for, for being able to control the browser, right? Now what we want to be able to do is be able to execute JavaScript outside of the browser, right? So we need the interpreting engine that is used in the browser. Well, you could use the same interpreting engine on a desktop, right? And that's what exactly Node.js is. Node.js is just an interpreter that can interpret JavaScript and run it on your desktop. And once you write a kind of like a hello world in JavaScript, maybe hello.js, then you can say node hello.js, and it will run your hello world. Yes, on the desktop. Now we're not going to actually code in JavaScript for the desktop, not until we get to halfway through the semester, right? We're going to still code JavaScript for the browser. Okay, so we're not going to use Node.js for executing JavaScript on the desktop. Instead, we're only going to use it because it's going to host, it's going to implement an HTTP server, right? That's going to host our React application. Yes, right? It's going to host our local React application, and that's why we're downloading it. And so that's why it has 3 executables: Node, which we're not going to use. We're not going to use till halfway through the semester. And then it also has npm and npx. Okay, npm we're going to use a lot, right? npm stands for Node Package Manager, right? And it does exactly that. It manages Node packages, Node executables, Node libraries, Node modules, things that other people write in JavaScript. We can install it locally on our machines and then run it, right? And the way you install it is you use npm. npm allows you to go to a repository, a very famous repository, npm js.com. So this is a repository of open source projects, right? That most people make it freely available, and then you can install all these packages into your Node projects. So one of the more famous ones and most popular ones is Express, for instance, right? There's a package that allows you to create servers, HTTP servers, right, in like 3 lines of code, right? And the way you install it is by typing this in the command line after you install Node. Right? You install it by typing npm install Express, right? It comes to this repository, downloads all the all those source code, right, compiles it on your machine, right, for your particular environment, for your particular operating system, okay, and now you have the libraries installed on your machine, okay. So we're going to be using that to install libraries such as Bootstrap, Font Awesome, React. All those libraries are coming up, so we're going to use that quite a bit. It also is used for running executables. Once you've installed it, right, then you can run them using npm start, npm build. You can build, you can install, you can run, you can do all sorts of things. Uninstall, right? Very much like other tools for C# or Java, right? And they all have their own package manager tools. Yes, npm is no different. So yeah, so we're going to use that quite a bit. The other executable that we're going to be using today, and I think this is the only time we're going to be using it, is npx. Right, so npx is the same as npm, but npm is for installing things, right, and then running it. npx allows you to do both at the same time. Download something, execute it, right, and not leave any trace behind. Right, the X is for executing. I want to be able to execute node packages. Okay, the node package that we're going to be executing is this one: create React app. So create React app is a package that is published by Facebook. Okay, it's a JavaScript package that can create React applications. Right? You can create the boilerplate a project with everything ready to go, so you can run your React application right out of the box. Right? Already compiled, already to go, already structured the way it needs to be structured. Okay, so instead of you having to do this by hand from scratch, right? They do all those configurations for you. So we're going to be using this. You can either install it and do npm install create React app, which is good if you're going to be creating lots of React applications. Then yeah, it makes sense to install it, right? And then just use it once it's installed. Or like what we're going to do, we're just going to create a single React application. So there's no need for installing it. We're just going to run it right away, right? And we're not going to leave any trace locally in our machine. Okay. So what we're going to do, instead of doing npm install create React app and then running create React, we're just going to do npx create React app, right, to execute it. So that's going to be that's why we first install Node, so that we have npx. Really, that's all we need it for installing. Once we install and create the boilerplate, then we're going to run our application using npm. npm can run node packages and things like that, right? Anyway, so let's create our first application. So you should create maybe from your home directory. Let's see, PowerShell. If we, so I'm in the home directory. I'm going to go to 2023, and so Spring. And then let's create a directory for this section. So CS5610-07. So let's go in there. There's nothing here. And so here is where we're going to create, we're going to do all our work in this directory. Okay. So throughout the semester, we're going to create a multi-tiered application, right? And so our application is going to be made up of several tiers, right, or several layers. The first layer, we're going to work the first half of the semester, is going to be a React front end. The second half of the semester, we're going to create a Node.js server for the middle tier. Right? They're both going to live in this directory. Both of them are Node projects. They're both Node projects. We're going to create the first of those Node projects, which is a React application. We're doing npx. So in here, in this directory, here I said web dev, but you can call it whatever you want. I called it CS5610-07. Okay, so we're going to run this npx create React app Twitter So we're going to be creating an application. Oh, I can barely see that. Huh? Get rid of that. Huh? That's annoying. Move it around.
Thank you.
Options at the top. Hide the view panel.
Oh, that's the video panel.
I think I'll have to leave the time.
You can make the window slightly smaller. Just put it in kind of
It's inside.
Oh, you could change how you're sharing your screen. You could share it to the full screen versus just
Is
the.
that what I'm doing? Oh. Nope. I'm sharing from there.
Oh,
When you made it skinnier, it showed the whole thing.
all right, that's worse.
It's so annoying. This might be an old. No, it's got apps. Okay, whatever. I'll work with this. Okay, well, I guess that'll do. Yeah, so I'll call it Twitter React dash web app, and this is for CS 5610 07 SP23. That's just so I know how to distinguish it from other sections I'm teaching. So anyway, so this is going to download Create React App, the module, and then execute it, right? And then remove it, so that as if it was never here, right? So it's creating a React application named Twitter React Web App CS5610, and so create a folder where that project is. Right, so that's going to take a little bit. So let's leave that going in the background. And so while that's going, once it's done, we're going to be able to go into that directory and run npm start. Right, and that's going to kick off the node server, and it's going to host our React application, our very simple React application, which is just going to say, just a spinning little icon, right? Then we'll make sure that we can share this code in source control, and make sure that you have a Git client. If you have a Mac, you should already have one already. If you're on Windows, you might need to install a Windows client, which I'm sure you already have. If you want a graphical user experience, source tree is a nice little graphical Git client. You can use that too. We're going to take a look at the source code once it's done. Are you done? Okay, it's done. All right, so there's the directory that I created. Let's go in there. You see? And we have in here the files and folder that I created. Now, what gives this out as being a node project is that it has package.json. Okay, that clearly tells me this is a node project. Okay? Also, just like if this would be pom.xml, that's a Java project, right? So there's certain configuration files that are very peculiar about different frameworks. Yes. Then we have node_modules. That's where there are all the libraries that this particular project depends on, right? So it downloaded all those libraries, right? Compiled them and put them under node_modules. Right? So it's tons of compiled code in there, right? And libraries. And so that compiled libraries should never make it into source control, right? You should always ignore anything that is compiled, any jar files, zip files, okay, any binary files, right? Should never go into source control. Anything that can be generated from source, right, should not be in source control. Make sense? Only the source control should go in there. So to that end, there is a .gitignore in there. See that? Which if you see the content, you'll see that node underscore modules is in there. See that? Node underscore modules is there. So this has already been configured correctly to ignore that node underscore modules, which is good, right? So that's not gonna, when we add the directory, this directory into Git, into service, into source control, it's not going to include node underscore modules, right? What else is in there? Okay, so also here we have two directories. We have public and source. Right? So public is a very common name for a folder where servers are going to look up content. Right? So if you ask for from a server, if you ask for a file, an image, an audio, whatever, right? It's going to look it up in that public directory. Right? So if you go, hey, server dot something something something, right? Slash, that slash is mapped to this public directory, right? After that slash, you can put all sorts of directories and paths, and it will be measured from this public directory. Make sense? And then it ends with a file that you're asking for, and that file should be in that directory. So, like the name suggests, anything you put in that public directory is publicly available to the server. Okay, so anything you don't want it to be public, you don't put it in the public directory. Okay. So yeah, so public is in there. So that mostly just contains HTML, CSS, and yeah, that's it. Where the magic happens is in the source directory. The source directory is full of JavaScript files, right? But written using the React.js framework modules, right? It's using a version of JavaScript that's a little more advanced than JavaScript, right? It's actually it's called JSX, right? So JavaScript is just plain old JavaScript. HTML is just plain old HTML. But JSX, right, is a combination of the two, right? It's JavaScript XML, right? It's JavaScript that knows how to manipulate or generate, right, XML stuff, which HTML happens to be a version of XML. Okay, so we're going to be spending a lot of time writing JSX. Okay, and so that's what's in there. And for that, we're going to wait a couple of weeks. Right, we're just going to tease you today for what's in there, but really we're going to spend more time later on this semester. Okay, what else is in here? Also not shown is the .git directory. There's a hidden directory called .git. That tells me that this is already a Git repository. Okay, and probably even it already contains all the files in that repository. Not quite sure, but we're going to add it anyway. We're going to add all the content into the Git just in case, and then we're going to push it to a public Git repository. So let's do that. Let's go create a. Well, first let's run this. See what it does. npm start. So that's use of npm, right? We've used npx, and probably never again. But if you want to create your own new React app, you can absolutely use that. And then we're going to use npm quite a bit for installing, uninstalling, running, building. There it is. So it starts, and one of the things that the script does is compiles, starts a brand new browser window, right, and starts the server, the Node.js server, right, and then it hits the Node.js server at localhost :3000. See that? Right. So this server is running in localhost, meaning our local machine, which you could also use the IP address, the standard IP address 129.0.0.1, which points to the local machine, and then listing at port 3000. See that? :3000. That's a very common port that Node.js developers use. There's thousands of ports, right? And each framework seems to kind of like take possession of a particular port, right? If you're using Java or like Tomcat, usually it's like 8080. It's a very common one. 8008. Those are a very common one. If you're working on Angular, typically is port 4000. So different frameworks tend to like gravitate to a specific port, and this is only for development purposes, right? When we deploy this on Netlify, there won't be a port number. Actually, there will be, but it's a standard port number, port 80. You know, HTTP servers, when they listen for incoming requests, right, they listen by default at port 80. It's so common that you don't have to provide the port number, right? They assume that it is port 80. Okay. Also, they assume that here, notice, we're not asking for any file. See that? We didn't ask for any content whatsoever. Right? But really, what we ask is for index.html. That is the file that is being rendered. Right? And an actual physical file exists, index.html, that contains this content. Right? But servers are configured to handle and assume that if you don't ask for anything, you must mean index.html. Right? That's why if you go to Wikipedia or if you go to any other of those websites, usually you don't provide the name of a file. Okay? It's because the server has been configured to show you a default content. Right? By default, usually it's index.html, but oftentimes folks, these companies will tweak their servers to name it something else like home.html or start.html or whatever. Right? But by default, index is the default entry point to a website. All right, so we have that. So we need to push this to a Git repository. So let's do that. Let's go to GitHub. And let's create a repository. So I'm going to use the same name as my directory just to keep it straight in my head, right? That these are they're one and the same. So I'm just going to copy that, and I'm going to create a repository that has the same name. And I'm creating this public. Please keep it public, right? Also, please use GitHub. Don't use the university's enterprise Git. Right? So please create a public one, a personal one, and leave it public so that you don't have to like add collaborators and you have to invite TAs or myself. We can all go and see that, right? Okay, so this repository is empty. There's nothing in it. So that's why it's showing these instructions, how to add content. So let's follow the instruction. I believe I don't need a Git init because it's I believe the repository already exists, but just in case, let's stop this. Control C will stop the server, right, and will kill the application. If I go and try to refresh, it'll fail. So if I refresh, it's going to say, oh, there's no server listening to at port localhost 3000. Nobody's there. So anyway, I'm just gonna follow git init. It'll probably say, yeah, it says I'm reinitializing. So I didn't have to initialize it, but that's fine. There's nothing bad there. So let's add. I'm not gonna add readme. I'm just gonna add the whole thing. So then git add everything. We made sure that git ignored did not include node underscore module, right? Did we do that? Yeah. We did. Okay. I think the assignment makes you add or at least check to see that
if you're using IntelliJ, the one thing you might want to do is the .idea.
Yeah, the assignment does do that. So the assignment tells you to add the .idea. If you're using Visual Code, it'll be something else. I forget. It's .ds something maybe. You should add for whatever IDE you're using. It will probably create a configuration file or configuration folder. Add that folder to the git ignore, right? Otherwise, as you're developing, it's writing to that folder. It'll ask you every time to like add that content. It's just a pain, right? So if you add it, it'll never ask you about it. Okay. Also, you don't know what other developers are going to be using, right? They might be using a different IDE, so it's it's useless for you to add it. So just please add that ignore. All right, so I added everything. So let's continue. So we're going to commit. We'll say git commit our first commit. There we go. And we're going to change the name of the branch. The default name of the branch is master. We're going to change it to main. So now the branch is main. So we'll say git branch. We are on the main branch. We used to be on the master branch. And then we're going to add this repository, right? This remote repository that lives in a remote GitHub server. We're going to add it as a remote. so that we can push from our local repository that we have on our local machine, we can push to the remote. Okay. So we use git remote add. Origin is a standard name, right? It's the default remote, right? So that when you push, if you just say git push or git pull, you don't have to every time say origin, right? It's understood that you mean origin, right? That it's this repository. I'm gonna copy that. I'm gonna add that remote, and now we can push finally. I'm gonna say push origin to main. And so that's gonna push the content to the remote server of.
It might be a different name.
Maybe I'm
If you
using my
copy
credentials.
it directly, it's probably a different.
No, I think I might be logged in to another repository. GitHub. Yeah, I'm logged into a different repo. Okay, let's try that again. Okay, then sign in with my browser. Okay, this. There we go. I think it now worked. Okay, there we go. So I was able to push the content. So if I go back to my repo, now if I refresh the screen, now there's content here. It won't show this default messaging. So if I refresh, this content should be identical to what I have locally, right? Except for the node underscore modules. Okay, so everything is there except for the node underscore modules. Pretty good? Okay. So once it's here in the GitHub, we can now deploy it to a remote server, right? Because here it's running locally on my machine. Well, it was. So npm start. Type. And so if I run it here on my local machine, it's great that it's running here on my machine. It's great for me for developing purposes, right? I can change everything and debug and whatnot, right? But no one else can see this, right? It's just me running on my machine. There's no way for me to say, hey, check out my great web application I'm building, because this is not publicly available on the internet. Yes. So instead, we need to push this and deploy this on a server that is publicly available, right? And that's where Netlify comes in. So create an account at Netlify. And once you create an account at Netlify, you can add a new site, import an existing project. The project can be either in GitLab, Bitbucket, Azure, or GitHub. We're in GitHub. So mine is already authorized. It'll ask your GitHub for permission to connect to it. So you have to log into GitHub. And then these are all the repositories that I have. There's hundreds of repositories. You can search for the ones for this semester. I call them all SP23. So I believe I have 3 with the one we created today. So I believe it's this one. CS56 07 SP23. And then it's going to deploy it. And it's going to say which branch. Well, it's only one branch. And it's going to run this command. It's going to clone down the repository. It's going to parse it, right? It's going to look at the package.json, look at the dependencies, and realize that this is a Node.js project. It's a React project, right? And it's going to install all the dependencies, right? And then it's going to build using npm build. All right. So let's do that. So while it's building, you can visit and look at the process. So it's built. It says it's building. If you click on that, you can see the what's actually happening on the remote server. Right. The remote server. The first thing that it clones the directory, right, and it parses it, and then realizes that it needs a particular version of Node.js. It needs a particular version of certain libraries. It installs all the libraries. It builds the project, right? And at some point, it'll say that it's finished. Okay, it's finished. think it's done. And it will choose a random name for your project. Okay, so it chose Grand Squirrel, and then some random number, hexadecimal number. Okay, and so for this course, it's fine. You can keep this. If you want an actual name, you have to pay for it. Right? You have to buy a domain name, right, and then associate it with this. Right, and they for a couple of dollars, you could do that, and Netlify will do that for you. Right, and so it's a paid service. You don't have to do that. You can just keep this squirrel. All right, so if you go to that squirrel, it gives you the URL of the application. If you click on it, right, this should look identical to what we have running locally on our machine. Right? Indeed, this is the one running locally, and this one is running remotely. See that? They're identical. Okay. So at this time, we're done with the assignments. What you need to provide to us are two things. You need to provide to us two URLs. This URL, right, for the repository, the Git repository, and you have to provide to us the URL for this having been deployed to a remote server. Okay. All right, those are the two deliverables for this assignment. Right, just copy those URLs, paste them into your submit when you submit these assignments. Make sense? All right. All right. Yeah, that's assignment 1. A lot of things can go wrong. This, of course, I've done it 1,000 times. I have the right things installed on my machine. I have everything, all the libraries are compatible with one another, right? And I've vetted out all the pains from before. And so the assignment does talk about some of those things, the ones that I know about, some of the potholes and that you might find, but hopefully I've been able to iron out that process. All right, let me see. Let's see. Node.js. We talked about Node.js. And we talked about creating React application, committing to GitHub, deploying. Awesome. All right. Let's start talking. Let's move on. Any questions so far? Pretty good? Did I lose anybody? Pretty tricky. Yes? All right. All right. Excellent. Let's talk about HTML. So HTML, as I had mentioned, right? HTML stands for Hypertext Markup Language. I'm big on acronyms, right? English is not my first language, and when I first came to this country, I felt like everybody was using acronyms, and I had no idea what anybody was saying, right? AKA or ASAP. It's just one acronym after another, and now I'm getting back at all those years of suffering. So all these acronyms, they'll be in the quiz asking, what does HTML stand for, right? So these are really basic stuff that coming out of a web development course, you should know your very basic acronyms, right? What does DOM stand for? Document Object Model. We'll see that in a minute. And CSS, HTTP, URL. Right. So those are some really trivial things that we should all know. So HTML stands for Hypertext Markup Language, and it's the language that tells the browser, how to structure the content on a web page. Okay. So here we have a browser, right? So somehow HTML is being used to tell the browser that on the left side, right, you have these scrollable widgets here, right, and these thumbnails, and on the right-hand side, to render this, this rectangle with certain things, yellow and blue and red and green, certain fonts and italic and bolds. Yes. So this is a browser, yeah. And it also tells the browser that there's a whole bunch of buttons like here, right? And then as I hover, there's a tooltip that should appear, right? All that is being generated by HTML and CSS. And so today and next week, we're going to spend some time talking about HTML and CSS. Okay. Same thing. And this is an application, right? This is not static content, right? It allows you to add content, move content around, right? Remove content, edit content. It's a full application. It's PowerPoint, right? But running on a browser. Okay, so that's what we want to learn how to do. How do we create applications, right, that interact with us, right, that create content, remove content, edit content, right, and it's usable not only on browsers but also on phones. Here's another one. This is another application. Canvas is an application, right, running on a browser. Okay, and so let's take a look at the HTML that was used to generate this. Okay, for instance, let's take a look at this quiz here. Quizzes. How was this quizzes rendered? Okay. So let's take a look. So if you right click on quizzes, okay, notice what appears. Okay, this menu that pops up, right, has a couple of options. One of those options is inspect. See that? Right? This is like when when Neo finally was able to see the matrix, right, and see what really is behind the matrix, right, and see the world how it really is, okay? And that it's not as pretty with these red buttons and nice columns and nice fonts, right, and all these nice borders and all the in reality behind the scenes, right, is just lots and lots of code. Okay, so behind the scenes is just lots and lots of very terse, right, dry code. Okay, all right, so this is like looking at behind the scenes, what really is happening. Okay, and that's what HTML, that's what CSS, that's what JavaScript together, right, come together to generate what's on the left side. So the left side is what end users see, right? And this is us, the developers, creating this content to make life nice for our users and clients and customers, right? So somebody had to write all this, right? That this was a unordered list, UL. It's an unordered list that has lots of line items, okay? Notice that as I interact with the right-hand side, the left side is highlighting and saying how they are related. Okay, that this piece of code here, right, generates this piece of content for the user interface. See that? Right? And our trick, what we're trying to learn is how can we generate the right-hand side the easiest way? Did somebody actually write this manually? Each UL, each line item? Okay, I don't think so, right? Somebody had to write some algorithm, right, that following a very complex set of logic and configuration and data structures, right, dynamically generates this left-hand side. Okay, and probably not just one person. It probably is there's a whole team that collaborated and have different responsibilities. Maybe somebody was responsible for this left-hand side navigation part, and there's the navigation team, right? And that's all they do, right? How to configure it, how reordering it, all sorts of things, and how it interacts with other tools outside, right? And then there is there's a modules team in the middle, right? And all these components come together, right, to build this very complex application. So there's a lot of software engineering behind this, okay? And maybe lots of teams working together to collaborate on this. So notice that as I highlight and say, if we look at these quizzes and we hate quizzes and we delete the quiz, notice that I can delete the line item, right? And the quizzes are gone, right? So I just broke Canvas, and oh my goodness. But well, no, I mean if I refresh, the changes we see are just only temporary, right? I'm editing on the right-hand side a cached copy of whatever was generated dynamically from whatever algorithm, which has been downloaded here in the browser, and the browser rendered it. Right. So this is a cache of what that was generated dynamically with some algorithm. What we're going to be learning is how do the algorithms generate this content on the right-hand side, so that we can draw whatever we want on the left side. Yes, as user interaction. Here I did it manually, right? I manually deleted it. We want to learn how to do that programmatically, right? Maybe by responding to some X icon, that we click on the X, right? And it poof, removes that content programmatically. That's what we want to learn. Not me, mocking around manually with this. Yes? Right. So what's here on the right-hand side, you'll notice is a very complex data structure. Okay. This data structure is referred to as the DOM, the document object model. Right? It's a hierarchical structure, right? It has a root, right? And has lots of nodes and branches, right? That eventually end up in some kind of leaves, right? So it's an inverted tree. There's a root, right? And all the leaves are dangling, right? And each node in this tree has a very specific part to play. Okay, let's start at the root. So all HTML documents start off with a root element or node or tag. I will often use those three terms interchangeably, right? But they slightly mean different things. Tags are, how we refer to it as a syntax of pointy brackets, right? Of how we visually see this text representation of an abstract node, right? A node is just an abstraction, right, of a tree-like structure. Yes, and that doesn't need tags, doesn't need pointy brackets, right? It's an abstract concept, but we write it in the syntax of pointy brackets everywhere, right? Of these tags. So it means the same thing, but not quite. Yes. So anyway, so these are nodes, and the browser renders this DOM data structure using these pointy brackets for our convenience, right? Because this is something that presumably was might have been written in just in an ASCII file. So conveniently is using this textual representation for our convenience. Internally, these are just nodes, with child links pointing to each other. Yes, right. But this is a nice, useful human representation so that we can parse it. Yes. Also, it renders it with collapsible nodes, right? So you can navigate through this nicely, right? Because it's very, very complex, right? But let's start at the beginning. So all HTML documents have a doc type HTML, right? So this just says that this is an XML document, but it has a specific vocabulary, right? It's using the HTML vocabulary, right? So XML is a very generic term, right? It just means that you're going to have lots of pointy brackets that can be nested inside of each other, and you can create a hierarchical structure, and each tag can have attributes and names, right? So that's what XML is, but not until you apply it for a particular use case is it of any use, right? So HTML happens to be one of millions of use cases for XML. Okay, you can use XML for for storing data, for storing configuration files, right? There's millions and millions of applications of XML, right? Which HTML is just one of them. That Tim Berners-Lee came up with. Ooh, I'm going to use XML to create the layout of a screen that I want to render in a browser. That was his, using an idea that already existed, but applying it to a very useful use case. Yes. So anyway, so this tells the browser this is an XML document, but not any XML document. It's an XML document that you should interpret as HTML, right? Meaning that it has a very specific vocabulary, that these tags has a very specific set of names, right? For instance, and structure. Right? So for instance, the root of all HTML documents starts also, always with an HTML tag. Okay, so this is the root HTML tag, and all HTML tags have two children, a head tag and a body tag. Okay, that's what HTML means. That you have these particular names for the tags, and they follow this particular structure. That's the syntax. Yes. So what does it mean? What do each one of these do? So notice that as I hover over them, it highlights on the left side. And it's telling you that this HTML is rendering the whole thing. But if I hover overhead, it doesn't highlight anything. It's telling me that head tag is not rendering anything on the left side. See that? But if I hover over the body, it tells me that's the one that's rendering everything on the left side. See that? Right? And that's exactly true. The head is not meant for rendering anything. It's only for holding just meta information. Things such as who the author is, when was this published, right? How does this document depend on other documents? Just meta information, right? Search engine things, right? Nothing that you would see actually on the screen. That's not true. There's one thing that you see on the screen, the tab. See this tab? That tab is configured in the head, right? In the title. Where's the title? Where's the title? Oh my goodness. Tons and tons of JavaScript. Did I?
You could just use the selector.
Okay, whatever. I can't find it. Oh, wait. Jeez. Oh, here it is. Title. And notice that it matches the tab. See that? I can actually edit it. I say, hello. Right? And notice that the tab changes. So that's the only visual thing that the head has. Okay. And also it lists all the things that this document depends on, like all these fonts, all these images, and JavaScript and CSS and all the other things that make things look pretty, right? The colors of the background, the foreground, the font. Yes.
Yeah. Are you able to also, like, text-wise, or like, are you able to affect the canvas and the image as well? Like, could you change it to something?
Yes,
else?
you can do that too. Yep. And so, but in general, the head doesn't render anything, right? It's not meant for that. Okay? So most of the content is just going to be in the body, right? In the body. And so if we hover over the body, we see that we have the name of the, all the tags have names. Also, they have attributes. Class here is an attribute of the tag body. Right? Actually, class is an attribute that is very common for all elements. Right? Most elements will can use class, and it's used to apply styling information. Okay, and all these styles have names, right? And that might say that certain things should be justified left, justified right. Use a particular font size, a particular background color, a particular foreground color, some padding, margins, borders, and whatnot, right? So we will talk about class next week, right? When we start talking about CSS, Bootstrap, and all that, right? So we'll spend that. But just to know that attributes allow you to configure the behavior of a tag, right? How it looks. All right. Other things here. This is a you saw that we can manipulate content, right? If I hover and I use quizzes, I can edit content. So I can change this to the exams. So now it changes to exams, and I can change perhaps some of the the styling that goes around with this. Notice that if I make this bigger a little bit on the bottom, notice that I have some more matrix behind it. See that? Written in an entirely different language. When you look at it, the above is all pointy brackets. See that? Whereas the bottom is all curly brackets. See that? Right? These are two entirely different languages. Right? The HTML above tells me the structure of the content, the relationship between the content, right? Whereas the bottom half is written in CSS, cascading style sheets. It's an entirely different language. That what it does is that it overrides the look and feel from the default look and feel of the page. Right? If we didn't have any CSS, all this would be drawn in a particular font, Times New Roman. Right? It would be all black on white. Okay, and it would look really, really boring. Right? It'll look all very, very flat. Okay, all just justified everything to the left. Okay, with no vertical, no columns whatsoever. Right, everything would be just one after another on top of each other. Right, CSS overrides that by telling you things that should maybe be drawn in columns instead of rows. Yes.
What's linking a bit of CSS to a line of HTML? Where's that link?
The link happens here on the left side. When you have these left-hand side, these selectors say all LI, all elements whose name is LI should have the following look and feel. Right? Should behave this way. Right? Who says that? This says that the user agent says that. User agent means the browser. The browser, by default, has its own styles. It needs to know that heading 1 is bigger than heading 3. Right? So those default styling come with the browser by default. Right? What we're going to learn when we learn CSS is how to override that. And says, oh, I don't really like Times New Roman. I'm going to override the font to be something else. Okay, the user agent will say that it wants Times New Roman. Right, and it wants heading 1 to be 28 pixels, right? Why? We can override and say no, use Arial, right? And I want it to be 32 pixels. Okay, we can override that with CSS. Now this comes. Notice that it's italic, right? And it says that it's being set by the browser itself. It's default. By default, lists are going to be rendered as list items. Here are our overrides. Right, this is an override that comes from that particular file that probably was linked, way in the header. The header downloaded the CSS file, just overriding the LI and telling it that it should not have any padding. Right, all LIs inside of unordered lists, inside of a navigation tab, inside of a div, inside of a view, should not have a padding. That's what it says. Right. So these on the left side are selectors, right? They allow you to refer to the DOM. The DOM has a hierarchical structure. Yes. So the CSS allows you to say, hey, navigate through a particular path in the tree, right? And grab that node and make it yellow. Okay. So that's what CSS does, right? It's very similar to XPath. Anybody play around with XML and XPath and things like that? Right. So XPath is a language, right, that allows you to use path information to refer to different nodes in an XML document and do transformations. Right. So CSS is a very distant cousin from that. Right. It allows you to navigate the tree using this syntax, right, and refer to different elements in the node in the document. And then paint them any which way you want. Yes? Right. So it uses a rule engine that runs this. It says, let me look for that. View div, yada, yada, yada. Is it? I don't know. Let's see. Here's an LI. It's inside of a UL. It's inside of a nav. It's inside of a div. And if it's so presumably, yes. Presumably this is true, right? Dot list, view, div, nav, ul, li, it's padding 0. Now we can override that. I would say 10. 10. And notice that this expanded, see that? So we are overriding. Obviously, this is all cached. I'm only manipulating the cache, right? And so notice that I'm overriding this rule, and it's applying to all the LIs. See that? And I can change maybe the background color to be yellow. Right, so they all turn yellow.
Individual line items. I can select a particular line item and only override that one line item. I can change the background color, right, to be red. Okay. Again, we're doing this all manually, right? The intention, once we get to JavaScript and React.js and whatnot, is to be able to do this programmatically, as through some algorithm or somebody clicking or dragging or typing or interacting with the user interface, right? And then do this programmatically, and then maybe save it to a database, right, as a preferences for my ugly colors, right? So next time I come back, I can keep my ugly colors, right? So that when I refresh, this will not be temporary. It will stick there. It will go to my database and find that these line items, I wanted them to be red and yellow. Okay, right, but that's a little later. Okay, so yeah, so the DOM, this is the DOM. We want to programmatically manipulate the DOM and programmatically manipulate the look and feel, right, using JavaScript. Okay, all right, so let's talk about JavaScript and for real. Let's go to the slideshow. How are we doing with time? All right, so HTML. So HTML stands for Hypertext Markup Language. And it's the language that browsers use to format web pages. So by default, if you don't have any tags, the browser will do its best to understand what you want to tell it. But in general, if you don't have any tags, it will not apply any format, right? So if you have, if you think you're formatting by adding any spaces or extra tabs or extra new lines, right? It will ignore anything. It will ignore all your formatting, right? Not until you explicitly tell it, right, to use a specific using specific tags, will it then actually apply formatting, right? So if you have something that is just plain text, it will ignore you thoroughly, right? So yeah, so most of the content will be plain text, right? And we will be adding those tags for formatting, right? So HTML pages typically have the .html extension, but .html also works, but I prefer .html, and it contains just plain ASCII text, right? So that you should be able to just edit it with just plain Notepad, right? A text editor. Obviously, if you use IntelliJ or VS Code, right, it gives you tons of type ahead and clues and syntax highlighting, right, that make it so much easier, because it's very, very easy to make a mistake, right? Very, very easy to open up a tag and not close it, right? And you want the help of an IDE to identify all those errors. All right, so here's a trivial hello world HTML document, right? It starts with HTML, head, title. Notice that I am using tabs, right, to just to show my brain, right, that this is hierarchical, right, and that they contain each other, right? But the browser doesn't really care about any extra tabs, any extra lines, any extra spaces, right? As far as the browser is concerned, this could all be munched into a single line, right? And we actually do that, okay? For speeding up the download of pages, okay? Usually we pass all our ASCII text, right, through a post processor, right, that will remove all extra spaces, all extra tabs, all extra which are unnecessary for the browser, right? They just add extra characters that need to be downloaded from the server, right? And every extra millisecond, adds up. Especially if you're not downloading just your HTML, but you're downloading a whole bunch of CSS, a whole bunch of JavaScript, a whole bunch of images and movies and audio and all the stuff, right? So everything adds up. Yes. So usually in production, right? In development is great that you have all these extra tabs and it makes it readable. But for production, when it gets deployed, usually passes through a post processor, which will remove any extra spaces and will obfuscate everything into, it will minimize it. It's called minimization. So there it is. We have a title. We have a link referring to a style sheet that presumably lives in the same directory, right, as this file. And this would just render hello world. Okay. You also have comments, right? Again, mostly for us developers, so that we can remember what we did last week when we were, debugging your code, right? So it could be, single line or multiple lines. Now what actually gets rendered is what's inside of the body. Everything else is just, we're downloading dependencies. For instance, we're downloading this style.css. So this style.css presumably is, we're going out to some other server that, lives half away, half across the world in Europe, right? And we're downloading the style sheet from there. Right? So the server is making at least 2 calls. I mean, the browser is making 2 requests. First to this document, and then a second one to go fetch this file, right? From halfway across the world, right? And downloading CSS. This one is downloading the style sheet from the same server that this document was downloaded from, right? Notice that it doesn't have anything in front of it. So it means that this is presumably in the same directory as our local file. Yes? Okay. So yeah, it's based on XML. The title, we talked about that. Links, body. Okay, so here we have a body, and we have lots of text. We have a tab. We have new lines. We have we have a new line over here. We have extra new lines here, and we're adding all these extra white spaces. Adding some structure to our content, right? Usually content consists of headings and paragraphs and lists and whatnot, right? And that's what we're doing. Maybe we have a title and a paragraph, maybe then another paragraph. We add the extra spaces, but when we render this on the browser unfortunately just mushes everything together, right? It totally ignores my extra spaces, my extra tabs, my extra lines, right? Because we haven't explicitly told it how to format any of this, right? So it ignores all the extra spaces completely. We have to explicitly say that we want this to be a paragraph by adding paragraph above and below, right? Just wrapping everything as a paragraph, and then it will add space above and below. Okay. So there's 2 paragraphs. Headings. So headings, like the name suggests, are for breaking up your content into multiple sections, right? And usually you might have like a main section or several main sections, and you might use H1 for that. And then each section might have several subsections, right? And you might use H2 for that, right? And H1, 2, 3, and so forth creates large, bold text titles or headings, right? That introduce certain sections. And bigger H1s, H2, H3, H4 creates ever smaller headings, right? H1 being the largest. Yes. Now both the paragraphs, both the paragraphs and the headings, they are referred to as block elements. Block elements. Okay. Let me tell you what that is. So for instance, bold here, which I was using here, what was it? Bold. Bold is not a block element. It's an inline element. Okay. The browser uses these 2 particular types of rendering all right, logical rendering to define how things are laid out on the screen. Okay, so most content is just going to flow from left to right, from top to bottom. In European countries, if you are in Israel or some Muslim countries, it might render the other way around. Right? So depending on the origin of where you are regionally, right, it might render from left to right or from right to left. Okay, and you can configure the browser to do one or the other, right? But here, while we're on the West, it will render from top to bottom and from left to right. Okay, but you can totally make it go the other way around, or from top to bottom. You can render from top to bottom and or from bottom to top, right? So you can totally twist the way you want to render, right? But here on this side of the planet, we're going to focus on from top to bottom, from left to right. So anyway, so content, as I mentioned earlier, just flows like this content, right? Like this text, from left to right, from top to bottom, right? And when it reaches the end of the window, it just wraps and continues in the next line. Yes, right? So, and usually what happens is that things that are most left just push things towards more to the right. Yes, and we call that inline. Things just flow, right? And when there's no more space, it just wraps into the next one, right? There's no vertical spacing. Everything gets pushed over to the right, and then when there's no more, it just wraps to the next line. Yes, there's no vertical spacing, except when you add. That's inline. That's the inline behavior, and most tags behave that way. You know, bold, italic, underline, right? When you want to underline something, it just gets underlined, but it stays still flowing. Yes, or if you want to make something bold, it's also, you want to still flow with the text. Yes, so most elements that change the look and feel of something behave as an inline. Okay, but those need to be distinguished from those that are not inline. Paragraphs are not inline. They are block elements. They add vertical spacing. See that? They break the flow, right? And they add a vertical space, right? Meaning, you know, you have the content at the top pushes things down, right? As opposed to inline pushes things right and then wraps, right? Block elements like paragraphs break up the screen vertically. Okay, right? Same thing, headings. Headings are also block elements. If you put that text in the head tag, right, it will break things vertically. Meaning, if I put them all in the same line, all these three things, even if I put them in the same line, they will render in separate vertically lines. See that, right? If they were in line, they would render one after another from left to right, just pushing each other to the right. Make sense? The difference? Okay. So yeah. So the browser uses this distinction of block and inline, right, as a major way of laying out things on the screen. All right. Okay. All right. The DOM. We already talked about the DOM, right? Tree-like structure. Lists. So list is another very common element that is used for listing things, right, that are presumably related to one another, right? So this is an unordered list, just listing courses that I have taught, right? And unordered means it's bulleted, and usually it'll have some padding on the left side, right? And it renders like a block, right? They're broken up in vertically. See that? Right? Now the content inside of the block is inline. Right? Whatever you put in here will flow from left to right in a wrap. Right? But LI behaves as a block element. And UL is also a block element. Right? It vertically breaks up the screen vertically. Right? OL is an ordered list that will render it in numbers, 1, 2, 3, and so forth. You can configure to render using Roman numerals or letters, A, B, C, D, right? Or lowercase letters, A, B, C, D, right? So you can configure how this, but the default is just 1, 2, 3, 4. Okay. So here's just more of that. Tables are also block elements. They break up a table, right, and vertically, and they're used for rendering tabular data. Okay. So tables allow you to define like a grid, right, that has lots of rows, right, and it has lots of columns. Okay. And they became very, very popular at the beginning when HTML just came out, right? Especially they were misused early on when HTML just came out, right, in the early 90s. Okay. Because lots of people started, producing a lot of content, right, for reading and whatnot, lots of magazines and newspapers, right? And usually these folks, the printed versions of these magazines, usually they use a lot of columns to break up long text. Yes, right. Usually magazines will have maybe at least 2 columns, or maybe 3, right? Or newspapers might have even 12 columns, right? And the intent is that you don't want to have very, very wide text because it makes it harder to read, right? Going from left to right, and then you come back, you miss where you started, where the line started, right? So usually what they do is that they break it up into small columns, so your eye doesn't have to move much. Yes, but unfortunately, HTML, as it was defined by Tim Berners-Lee, had no support for breaking up content in columns. Okay, but it had tables, but not for breaking up content in columns. It was meant, right, for tabular data, not for breaking up content in columns, right? It was meant for like a database, right? Each row was like a record, right? Where you had columns, and all the columns were of the same data type. Okay, one column would be all dates, right? Another column would be all currency, right? Another one would be some Boolean, or maybe some double, right? And we have data, about quizzes, right, and whatnot. Yes, and you had records. So that was the original intent of tables, for tabular data. But folks that were not researchers, that didn't care about that, said, "Ooh, this is perfect. It allows me to break up the content in columns." So they were originally misused for this, right? And so I would ask you not to do that. Don't misuse tables for that. Instead, we will teach you how to use CSS and divs and other elements to properly use that instead, to break up things in columns. All right. Okay. So tables only for tabular data. So here's an example. So table has 3 children, of which I'm only showing 2. T head, T body, and T foot. Okay. So table has those three elements. The T head is for displaying the first row of the table, right, with headers, the headers of a table, and the head is basically just one row of multiple columns, right, where the names of the headings are. Yes, and then the foot is also just a row of maybe resulting values, maybe averages or totals or sums that have added up an entire column. Yes, maybe you want the whole average value of a whole bunch of records. Yes, right. So that's where you put it in the foot, and the body contains the main content of the data, right? So each one can contain rows. So T head can contain rows, T body can contain rows, T foot can contain rows, and then each row can contain any number of columns. Yes. So let's look at a couple examples. So here's in T head. T head has one table row, TR, and then the table row has a whole bunch of columns, TH. TH for T head. So TR for table row, and T head for table heading. Yes. So here you have a whole bunch of table headings: username, password, first name, last name, role, and there it is. Right. There's our row, right, with the headings. Notice that they're bold. Okay, they're nice and bold and probably center, I believe. I forget. Okay. Then you have in the body is where you would have the actual data. right? In the T body, here's a T body containing a single row, right? For the values of Alice, right? Alice, password, Alice first name, last name, right? Her role, and then edit and remove. See that? Right? And it renders it in a row. I didn't have space to put the Bob, right? But it would be right under here. TR for Bob. Yes. Okay. Other elements, we have the inputs, dates, drop downs. So this is form elements. So up to this point, was content for read-only content, right? Content for us to read through, right? In tables or lists and whatnot. We want to be able to interact. We want to be able to interact with our application, right? We want to enter data too. We want to click and drag and type and enter data, right? And for that, we have input fields, right? Input fields allow us to type, any piece of content, right? Like a last name or first name or whatnot. Okay. And these input fields, right? They have several attributes that allow you to configure the behavior of that input field. For instance, it has the placeholder Alice. See that placeholder Alice? And what that means is that see it says Alice is grayed out, right? It's grayed out, kind of giving us a hint, right, or an example of what it is that we're asking for. Right? It's always a good idea to give the user kind of a hint of what it is that you're asking us to type in there, right? So to give us an example, right? Also, notice that it has a title equal username. See that? Right? It's not showing. But what the title does is that if you hover with your mouse, right? If you hover with your mouse over the input field, right, it'll come up with a tooltip. Like a little tooltip saying, oh, it may be some kind of explanation, right? Saying, please type your username or whatever, right? And it has to be unique or something. Yeah, so that could be a help for the user. Okay. Also, we have this type equal text. See that? Type equal text says that this input field can have many types. Right? We could say that this input field is an email, or this input field is a date, or this input field is only numbers. Okay, and so that tells the input field to make sure that if we're asking for numbers, not to allow folks to type characters, right, non-numeric characters, or that if we're asking for an email, well, the input field will make sure that there's at least an @ sign, right? That has a dot in the domain. Yes. So we'll do some validation. Okay. So the type allows you to add some meaning to the field. Now, by default, if you don't say anything, the type is text by default. Text means that it's anything. You can type whatever you want. There's no validation, right? It's unrestricted. Yes? Okay. And that's the default. Here in the input, if you could possibly see it. Yeah. This input, for instance, doesn't have a type. See that? Doesn't have a type. That means by default is text, right? So meaning I can type anything I want here. No validation whatsoever. Okay.